Hello everyone. Today we are going to discuss the chapter Matter in Our Surroundings. Before going to the chapter, please subscribe our channel Nirja Education and don't forget to press the bell icon. The first topic, that means the effect of temperature, already I discussed for interconversion of states of matter. The effect of temperature already I discussed in my previous video. If you haven't gone through that video, please go through that video. In this video we are going to discuss about the effect of pressure for the interconversion of states of matter. How the pressure will affect for the interconversion of states of matter. Already I told you that the gas particles, the intermolecular space is very large. They are free to move. They are very free to move. So to change a gas, you have to apply the pressure. This is known as compression of gas. Compression of gas. Compression means you are applying pressure, you are increasing the pressure. You can see this in syringe also. Syringe we are increasing the pressure, then the piston will move inwards. The piston will move inwards. That is what is happening in compression also. We are applying pressure there. When we are applying pressure, the particles will come closer. The particles will come closer and they will change from gaseous state to the liquid state. They will change from the gaseous state to the liquid state. This process is known as liquefaction. This process is known as liquefaction, the conversion of gas from the liquid by applying pressure. That means by increasing pressure, this process is known as liquefaction. One more condition is there for liquefaction, that is the temperature should be reduced. By lowering the temperature and by increasing the pressure, we can change a gas from a liquid state. So this process is known as liquefaction. How this is happening, I will explain once again. When you are applying force, the particles of matter will come closer. The particles will come closer. They are coming closer means the force of attraction will increase. The force of attraction will increase and the molecules will bind together and they can convert from one state to another. That means from gaseous state to the liquid state. In this case, we will discuss two terms, that is critical pressure and critical temperature. Critical pressure is the pressure in which we can convert a gas from a liquid. Critical pressure is the pressure in which we can convert a gas from a liquid. The next one is critical temperature. What is critical temperature? I already told you that you have to lower the temperature, then only you can convert a gas from a liquid. So critical temperature is the minimum temperature in which you can convert a gas from a liquid state. After, if you are lowering the temperature, we can't convert a gas from a liquid. If you are applying pressure also, you can't convert a gas from a liquid. So these are the effect of pressure on the interconversion of states of matter. Next we will go to the next one, that is evaporation. Next topic is evaporation and the factors affecting evaporation. Next we will see what is evaporation. I think all of you know what is evaporation. What is evaporation? The phenomenon in which the liquid changes into its gaseous state below its boiling point. You should be careful that below its boiling point. The liquid changes into gaseous state below its boiling point, that is known as evaporation. Actually evaporation is the surface phenomenon. When you are heating means below, before the boiling point, the liquid state, from liquid state the particle will change into gaseous state. You can see that one. Before boiling also you can see the vapors coming out from the water. After some times only the water will start boiling. So this is a surface phenomenon because the molecules, here you can see the molecules from the surface will get energy and they will get more kinetic energy. So they are in surface, so they can escape fast. other than the particles in the bulk, because they are in the topmost, that means upper side. So it is a surface phenomena. The particles of this surface will escape first. So evaporation is a surface phenomena. So you have to know the difference between boiling and the evaporation. Boiling means it's a bulk phenomena. The particles from the bulk also will escape. But evaporation means it is a surface phenomena. The particles from the surface is escaping first, because when getting kinetic energy they can escape fast. This evaporation is occurring before boiling point, that you can watch also when you are boiling the water. Before boiling, you can see the vapors are coming out from the water. So that is the difference between this boiling and evaporation. Evaporation is the surface phenomena and boiling is the bulk phenomena. Next we will see what are the factors affecting the evaporation. What are the factors affecting the evaporation? The first one is surface area. The first one is surface area. If surface area increases, the evaporation also increases. If surface area increases means the evaporation also increases, because surface area increases means the part will be more, the area will be more, so the particles can escape freely, they can escape fastly, so that the area is more. That is the reason if surface area increases means the evaporation also increases. The second one is temperature. This already we have discussed. When we are increasing temperature means what will happen? Evaporation increases or decreases? Yes, obviously it will increase. Why it is increasing? Because when we are increasing temperature, they are getting more kinetic energy. The kinetic energy of the particles are also increasing. When kinetic energy increasing means the particles can move freely and they can break the force of attraction between the particle, so they will change from liquid state to gaseous state. So when we are increasing temperature, the evaporation is also increasing. The next one is humidity. What is humidity? You know that. What is humidity? The amount of water vapor present in the atmosphere, that is known as humidity. If already the amount of water vapor is more, that means humidity is more, the atmosphere can't accommodate more water vapor. There is some limit for accommodation of water vapor. So it can't accommodate more water vapor. So when humidity is more, the rate of evaporation will be low. When humidity is more means the rate of evaporation will be low. The reason is that they can't accommodate, the atmosphere can't accommodate more water vapor or water molecule. That is the reason. So humidity increases means what happens? The rate of evaporation decreases. The next reason is that wind speed. This humidity also, you know that sunny days, when it is sunny days, the cloth will dry fast, but humidity is there means what will happen? It will take some time to dry the clothes, because the same reason only, due to the evaporation, the rate of evaporation will be less there due to the atmospheric humidity. Already the particles, water vapors are there, so it can't accommodate more water vapor or particles. The next is wind speed. Wind speed also we know that when we are blowing wind, the particle of water vapor will move away with the wind, so it will dry, the cloth will dry fastly. That means the rate of evaporation is increasing. When wind speed increasing means the rate of evaporation is also increasing. This is one or another reason. When wind speed more means the rate of evaporation will also more. The next one is nature of liquid. Nature of liquid means we know that the boiling point of the liquids are different. For water it is 100 degrees Celsius. In some of the liquids the boiling point at room temperature also it will evaporate. Example acetone. You know that nail polish remover. So that is acetone. Acetone in room temperature, if you kept open the bottle, it will evaporate at room temperature also. So we have to consider at the boiling point of the liquid also. If boiling point is less means it will evaporate fast. Boiling point less means it will evaporate fast. So these are the some of the factors which affect the evaporation. I will explain once again: surface area, temperature, humidity, wind speed and nature of the liquid. These are the factors. Next we will see the cooling effect of evaporation. The cooling effect of evaporation. So what is the reason for the cooling effect of evaporation? So already I told you that this evaporation is a surface phenomena. It's a surface phenomenon. When we are giving heat, when we are providing heat, these particles are getting kinetic energy. So there is a competition between these particles who will escape first. There will be a, because everyone like freedom. Yes or no? Everyone like freedom. So there will be a competition between these particles. So the particles at the surface will escape first. The particle at the surface will escape first. So the average kinetic energy of the system is decreasing. Why? Some of the particles are outside the system. Some of the particles, that means they are escaped from the system. Now the number of particles inside this container is less. So the average kinetic energy will be less. To regain the energy, to regain the temperature, what will happen? This system will absorb, the system will absorb the heat from the surrounding. The system will absorb the heat from the surrounding. So the surroundings will have a cooling effect. That is why the evaporation causes the cooling effect. I will explain once again. When you are providing heat, the particles will get some kinetic energy. So there is a competition between the particles and some of the particles will escape from this system. So the number of particles in this system will be less. In the system will be less. So the average kinetic energy of the system is decreasing. So to regain the energy, what will happen? They will regain the energy from the surrounding. That is why the surrounding will have a cooling effect. One more example is that already I told about the acetone. When you take acetone in your hand, you will feel the cooling effect. Why? Because it will absorb the heat energy of your palm and it will evaporate, because we are not providing any other heat. So it will take the energy from your palm or the surroundings and it will evaporate. So that there is a cooling effect for this acetone. I hope all of you have understood all these topics, that is evaporation, effect of pressure on the interconversion of states of matter. Thank you all and have a nice day.